What is Euler's buckling formula, used for in design against buckling? Imagine a tall, slender column supporting a building or a bridge. It looks simple, but underneath, complex forces are at play. When a long, thin member like that is compressed, it might suddenly bend or collapse without warning. That's where Euler's buckling formula becomes a key tool. This formula helps engineers figure out the maximum load a slender piece can handle before it buckles. Instead of just crushing under pressure, these members tend to bend sideways, causing failure. The formula predicts that critical point, so designers can avoid pushing structures beyond safe limits. To understand how it works, think about a straight, smooth rod or column. When you push down on it, it resists up to a certain point. But if the load gets too high, instead of compressing straight, it starts to bend. The formula considers how stiff the material is, how long the member is, and how it's supported at the ends. For example, whether the ends are fixed, free, or pinned makes a difference. Engineers use this formula to design all sorts of structures, from skyscraper columns to towers and bridges. It helps them choose the right materials, the proper cross-sectional shape, and the correct length so the structure won't buckle unexpectedly. If a structure already exists, the formula can be used to check if it's still safe or if it needs reinforcement. The formula assumes the member is initially straight and that the load is perfectly aligned along its axis. It also assumes the material stays within its elastic range, meaning it doesn't permanently deform. These assumptions make the calculations reliable for initial design and safety checks. In practical terms, if a steel column is 10 meters long and has a certain cross-sectional shape, the formula can tell you the maximum load it can carry without buckling. If the load exceeds that, the column might bend and fail suddenly. This helps avoid costly failures in buildings, bridges, and mechanical parts. Designing against buckling is a big part of mechanical failure prevention. Euler's buckling formula is a simple yet powerful way to predict when buckling might happen. It guides engineers in making safer, more reliable structures by understanding exactly how slender members behave under compression. Knowing this helps prevent unexpected collapses and keeps everything around us standing tall and strong.